Okay, so last time we were looking at the union of infinitely last time we looked at the union or the intersection of countably infinite number of events. So what we said is basically the following: the union n going from 1 up to infinity of En, and if you remember, this is the event consisting of all outcomes that are in En for at least one value of n. So that was the union of the events En, and the intersection of the events Ens is the event consisting of all outcomes which belong to En for every n. Okay. So an element is in the intersection if it is in every single events, right? And an element is the union of the events En if it is in at least one of them. Okay. So notice that X is in the union of the Ens if X is in one of them for some n, and also X is in the intersection of the Ens if X is in En for every n. Okay? You guys understand the difference? Okay, so just like we had DeMorgan's laws for union of two events or two sets, we also have DeMorgan laws for the union of countably infinite number of events or sets. So here are the DeMorgan's law DeMorgan's law number one, it says that the union n going from 1 up to infinity of En, and if we take the complement of that, what we get is the same as the intersection n going from 1 up to infinity of the complement of En. Okay. And number two, if we have the intersection n going from 1 up to infinity and the complement of that, then that's the same as the union of En complement. Is everybody clear on that? Now, so for example, why is number one true? So let's justify number one. Let's justify number one. So let's say proof of 1. Well, let's take x on the left hand side. So if I pick x in the left hand side, the union n going from 1 up to infinity En complement, right? If it is there, what does it mean? It means that x is x is not inside of the union, right? Is everybody clear? If x is in the complement, right? What happened to that? So this is n from 1 to infinity. So if x is in the complement, then x is not in that set, right? Well, if x is not in that set, what does that mean? It means that x is not inside of En for any value of n, right? X cannot be En. Otherwise, it will be in the. If it is in some En, then it's going to be in the union, right? So that tells me that x is inside of the complement of En. If x is not in this event, then it's got to be in the complement, right? So x is in the complement for any n. However, what does that mean? Well, it means that x is in the intersection of all the x is in the intersection of En complement, right? So what I've shown here is that if x is in the left hand side, then x is in the right hand side. Now if you pick x in the right hand side, right, how do you show that x is in the left hand side? Well, you just have to reverse my steps. So you say that x is in the right hand side, and then you can say x is in the right hand side, and then you can say x is in En complement for every n, which would mean x is not in En, right? Which would mean that x is not in the union, which would mean this. So you just have to reverse my steps. Or let me just write if and only if, and that completes the proof. Okay, so that's how you can justify the DeMorgan's laws. You should try the other one on your own. Any questions on that one? Okay, here's a remark that I needed to make that I probably should have made earlier. What is a discrete sample space? A discrete sample space is either a sample space that is a finite sample space, which means it has only finitely many outcomes, or it could be countably infinite. It could be countably infinite. Okay, that's what a discrete sample space is. Now, what is the meaning of countably infinite set? What's the meaning of countably infinite set? Countably infinite set means, so if you have a countably infinite set, what it means that that set is in one-to-one correspondence with the set of positive integers. So a set S is countably infinite if there exists a one-to-one correspondence if there is a one-to-one correspondence from S, or let's say from the positive integers n, the set of positive integers n into S. So in other words, you can express the elements of S as an infinite list. In other words, you can express elements of S as an infinite list. So something like A1, A2, A3, Okay? So you can express them by using the positive integers as subscripts. Okay? Everybody's clear what we mean by a discrete sample space? Any questions on that? All right. Let's do an example now. And I am going to bring back one of the examples we did earlier. Let me find that. So let's say you are measure the lifetime of a transistor and so in this case the sample space will be the collection of all values of x where x is between 0 and infinity, right? And so let's define some events now. For each positive integer, n, define en to be the event that that the transistor lasts at least n hours. Okay. So can somebody express En symbolically? So this would be the values of x for which what? How would you express the event En symbolically? It's all values of x for which x is what? How would you express that? Can x be anything? Was that positive integer? I mean, x could be, it's the lifetime, so x could be 3.14 hours, right? Greater than what? Yeah, because what we are saying is the event that a transistor lasts at least n hours, right? So this is the all values of x such that x is at least n. Okay? Now, let's try to figure out what's the union. So how many events have I defined? How many events have we defined? Not one. For every n, for each value of each positive integer n, I have an event, right? So I have countably infinite number of events here. So what's the union? What's the union 1 to infinity of En? Anybody? What is the union? Okay, I'm giving you 40 seconds, and if you can answer me, then I'll give you some extra points. 15 seconds. Okay. Yeah, go ahead.
X in the union
So what is the answer? The answer is you're saying the complement of En. So what's the? So what is this union? What's that?
The complement. I don't know how to say it. Number 2, the morning ball.
Well, there is no complement. I'm not taking any complement here, right?
Oh, all right. Number 1 and 1.
Well, again, we don't have any complement, so we are not applying DeMorgan's law here. So all I'm saying, you know every En, right? Well, look at En. What is En? Can you write down E1? Can you write down E2, E3, E4? Okay, then think about what should be the union. I'm sorry? EX. Just En? The union of all Ens, just En? Yeah? Yeah?
Just be the events from maybe E1.
Well, we have the union of all the E1, E2. So this is the union of, E1 union, E2 union, E3 union, right? It is that. What I'm saying, what is that equal to? Just En? Could you write down what E1 is? Go ahead and write down what E1 is explicitly. What is E2? Explicitly write that down. Can you do that? What is E1? E1. Does E1 contain E2? Is that true? E1 contains E2? Well, look again. What is E1? E1 would be all values of x such that x is larger than 1. What is E2? Values of x which are larger than 2. Which one is bigger? E1 goes from 1 to infinity, right? E2 goes from 2 to infinity, right? So E1 contains E2, right? Same way E2 contains E3. Am I right? Let me show you the number line here. Whoa. So here's the, not again. So here's the number line, right? And so what is so let's say this is so E1 is everything to the right of 1, right? And what is E2? E2 is everything to the right of 2, right? Let's say 2 is here, right? So which one is a bigger, which one E1 contains E2 then, right? So same way E3 contains E4 and ... okay? Is that making sense? So what's the union then? E1, right? The union is just E1. Is everybody clear on that? Okay. Now, what's the intersection? 1 to infinity of En. What's the intersection? Anybody? En? No. What's the intersection of all? So it is the so this is what? This is the intersection E1 intersect E2 intersect E3 intersect dot 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 intersect En intersect En plus 1 intersect dot dot dot. Yes.
E2 minus E1.
E2 minus E1, okay? No. There is no E infinity, right? For every positive integer n, you have En. So there is nothing called E infinity. I don't have, I didn't define E subscript infinity, right? Was that? There is no E0, E1, E2, E3. E1 is the union, so why should it be, what's that? 0. But what do you mean by 0? Empty set, very good. Right? So this is empty, right? Do you agree with that? Let's see. If you say that something is in every one of them, right? What is that? What would that mean? If you say X is in the intersection, right? Wouldn't that mean, so X in the intersection, oh, I forgot to write intersection. So X is in the intersection of the En events will imply that X is in En for every n, right? But what is the meaning of X is in En? X is in En means what? X is larger or equal to n for every n, right? If X is in En, remember En means all the values of X greater than n, right? So if X is in En for every n, then X has to be bigger than every single positive integer, right? Can you give me a number which is greater than every single positive integer? No, right? Is that making sense? So there is no X which is greater than every single positive integer, right? So therefore, this intersection is empty. Any questions on that? Everybody's okay with that? All right, so that concludes the topic on, so what we learned so far about we learned the last 2 days, I guess, sample spaces, events, operations of events, right? Things like that. Okay? Pretty much the set theoretic terminologies is what we have learned so far. Any questions, anybody?